Hello everyone, welcome to my first video. In this video, I will show you how to create a Gradle convention plugin to measure test code coverage using Jacoco tool. Next, we will connect it to Gitlab CI/CD. It can be especially useful for your production code. So, let's get started. First of all, let's create an empty Kotlin Multiplatform project to learn how to integrate the Jacoco tool. We will choose Kotlin Multiplatform application. The name can be playground. It's up to you. Next. And finish. We have created project and now we can create our first convention plugin. But first, let's remember what the Gradle convention plugins are. These are powerful tools for using build configuration. They allow you to define a set of conventions for your Gradle builds, which can then be applied to multiple modules and projects. It can greatly simplify build management, maintenance, and increase efficiency. I will set up the ignore file. If you want, pause the video and look at the contents of the file. I hope everything is clear here. And now we will create a directory named buildLogic on the root of the project. I will create a setting Gradle configuration file. The file is responsible for managing buildLogic, build automation, and configuring our Gradle version catalog, which we will want to use later. We use a dependency resolution management block containing a repository block. We added Gradle plugin portal as a repository for plugin dependencies. We declared the Gradle version catalog. Root project name, build logic. It assigns a name to the build. Next, we will create a build Gradle file. Plugins block and Kotlin DSL. Then we add a repositories block containing Google, Maven Central, and Gradle plugin portal. Dependencies block. The dependencies we want to use aren't yet defined in the version catalog. We will add to do and add them later. And we must also remember to add include build to the settings Gradle file in the project root. It's done. We can sync the project, and Gradle should recognize the build logic directory as a module. So far, everything looks good. We create a new file that we can name Jacoco Kotlin. Now, let's add the dependencies to the version catalog. We add the latest version of Jacoco, and it is 0812. And we can also add the codest version of the library. We will also add our plugin. It's the name of a file we created a while ago. We will also add plugins that we will need. Accessing the version catalog from precompiled scripts now has limitations, but there is a workaround that will allow us to do this. You can find more information about it at this link. We sync the project. Now we can solve the to-do. Dependencies from the version catalog are now available. We sync the project. We add the Jacoco plugin. To access the version from the version catalog, we need to add this line of code. Now we can register a task that will generate a detailed code coverage report in HTML format, visualizing coverage data with color-coded bars and charts. Name is Jacoco test report. A report task depends on test task. We can set group and description. Temp, Kotlin classes, debug, and we can set our package com Gitlab. We set class directories to compiled Kotlin classes, excluding specified exclusions that can be defined in the file filter collection. Now we set source directories. Common main. Android main. The last one is iOS main. We set the execution test data result. The Jacoco report task can be used to generate code coverage reports in different formats, like XML, CSV, and HTML. Add our plugin to the shared module where we want to use it. We will open terminal and check if the Jacoco test report task is available. We run the command. Here we can see it. Everything looks good. Let's write some tests. We will create a simple calculator for which we will write tests. We create a calculator class that will have a calculate function. The function will have a one string parameter. The function takes a simple mathematical operation, parses it, and returns the result. The result is of type int. First, we will write the test. And now we create subdirectory for tests in the common test directory. Let's create a calculator class where we write test for the calculator class. Oh, I forgot to create a package. This methodology is called test-driven development. It's a software development practice that focuses on creating unit test cases before developing the actual code. It's a very helpful methodology. The developer will see cleaner and less bugged code development. It may be an interesting topic for another video. Let me know in the comments if I should make a video about it.
We add the code is assertion dependency to shared module. When writing test cases, it's common to need to verify the type of an object. For it, we use the code assertion core dependency. It provides convenient assertion functions that allow us to perform this type of checks effortlessly.
We sync the project.
Sync the project once again. We create instance of calculator class. And we are finally going to write our first test. Should parse string and multiply two numbers. We call the calculate function and pass the parameter simple multiplication of two numbers. Check that the result is an instance of type. Oh, I don't have a synchronized project. We check the multiplication result. We create a similar test for dividing two numbers. Other mathematical operations will not be supported. In other cases, we throw illegal argument exception. With message and valid operator. Now, we can clearly imagine what the function should achieve. Let's run tests. As we expected, tests failed. Now let's implement the logic of the calculate function. We use the regular space character to split our string parameter. In one block of code, we recognize supported operators and implement them. We will run tests and they should be successful. Tests passed. Let's generate a code coverage report. Run the Jacoco test report command into terminal. We have generated it. Let's open the generated file. A new directory Jacoco HTML was created in the build directory of the shared module, where the generated report is located. In the report, we can see which part of the code is covered by tests. Now we create a Jacoco coverage verification task to use in Gitlab CI/CD. The task can be used to verify if code coverage metrics are met based on configured rules. Its API exposes the method violation rules, which is used as my entry point for configuring rules. Invoking any of those methods return an instance of Jacoco violation rules container providing extensive configuration options. The build fails if any of the configured rules are met. Jacoco only reports the first violated rule. We remove reports methods and replace them with violation rules. We set a limit of 70% test coverage. We should see an error message when verification task fails. Let's try to run it. Task failed as we expected. Instruction covered ratio is 61%, but expected minimum is 70%. We changed the limit to 61% to pass the task. Now we can set up Gitlab CI/CD. Let's create a configuration file Gitlab CI.yaml at the root of the project. I'm using Docker runners, so I set up a Docker image. It's available on the Docker Hub. We set execution flag on our Gradle file. We set up caching for Gradle. We create a test stage. Now, we create a verification job that will run automatically when a merge request is created. We used test stage. We set Jacoco test coverage verification command. Except main. And only merge request. Let's commit and push changes to Git. Now we can see the progress of the verification job. Nice. Build was successful. The pipeline passed. We can see that the merge button is enabled. We are at the end of the video. Thank you for watching. Don't forget to support me by liking and subscribing. It will motivate me to create more videos for you. Have a nice day. Bye.